Hey everybody, so in this video I'm going to be talking about, well, a little bit just sort of general how you handle two and three-dimensional kinematics and projectile motion in specific. And this is mostly in chapter 4-5 in the textbook. All right, so first off, so two-dimensional kinematics, or three-dimensional kinematics for that matter. So the key thing is that as long as your coordinate axes are perpendicular to each other, motion in each direction is perpendicular, is independent. So that is the key thing about multidimensional kinematics. Right, so typically if you think about like a two-dimensional XY coordinate system, right, so you take X as your horizontal direction, Y is your vertical direction, those are perpendicular. So what that means to be perpendicular is that whatever is happening in this horizontal, the X direction, is independent from what's happening in the vertical or the Y direction. Now, that's important because that means that you can separate the motions in those two different directions. And in particular, that means since you can treat them separately, what it really boils down to is that you can treat a two-dimensional problem as two separate one-dimensional problems. Or if you have a three-dimensional problem, then you've got three separate one-dimensional problems. So that is the key. Set up your coordinates to make sure your axes are perpendicular, and every standard coordinate system always has perpendicular axes for exactly this reason, and that means you can separate out the motion in the different directions. Okay, so, and then if you have a two-dimensional kinematics problem with constant acceleration, well, constant acceleration says, yes, we can use the kinematic equations that we all know and love, but then we need to write these as vector equations, right? So one of our kinematic equations, v final equals v initial plus a times t. Now here I've specifically put in the little vector symbols since our velocities and our accelerations are vectors. But in practice, the way you do this is just to remember that, okay, if I have a vector equation, well, that's just equivalent to two or three equations involving the components, right? If you have two components, you've got two separate equations. If you've got three components, you've got a third, right? So the final velocity, the component of the final velocity in the x direction is equal to the component of the initial velocity in the x direction plus the component of the acceleration in the x direction times t, right? And a similar one involving all the y components and a similar equation involving all the z components. Okay, which brings us to projectile motion. So what we mean by projectile motion is that we have an object moving freely through space only under the influence of gravity. So gravity is the only force acting on our object. So in particular, this means that, well, no rockets, at least, right, no rockets with functional rocket engines because that exerts a force. No planes, because, well, planes have engines that exert forces, they have wings that exert lift, which are more forces, or air resistance, right? Air resistance is just another force. So here for projectile motion, that only holds if air resistance is negligible and we don't have any wings with lift or engines or anything like that. So gravity should be the only force acting on our object. And again, we're going to assume g is constant, so acceleration due to gravity is constant. And this works as long as we're relatively close to the surface of the Earth, right? Well, then it's going to be 9.81 meters per second squared downward. In principle, acceleration due to gravity does change a little bit with elevation, although your changes in elevation have to be pretty big before you have to worry about the acceleration due to gravity changing. Okay, so again, as long as we're near the surface of the Earth, acceleration is going to be in the vertical direction and 9.81 meters per second squared downward. And in the horizontal direction, well, if gravity is our only force, there isn't any air resistance or any other forces, then we're not going to have any acceleration in the horizontal direction. So if we have projectile motion, then there's two things we will automatically know. Acceleration in the vertical direction is just going to be acceleration due to gravity. And again, 9.81 meters per second squared downward, as long as we're near the surface of the Earth. And the acceleration in the horizontal direction is going to be 0.